What's going on, everybody? I'm Eric from Panola College, and we have a couple of other intro things that we want to introduce in this video in our continuing series of Introduction to Wireshark and overall cybersecurity concepts. Now, if you like these, go ahead and send a like and subscribe. Give us some ideas in the comments on stuff that we may need to cover in the future or that you want to see us cover. This is generally stuff that we introduce in our cybersecurity courses at Panola, and we just enjoy you being around. So in this one, we're going to be covering a little bit more into Wireshark and kind of correlating with PIDs. Now, what are PIDs? Process IDs. And this is an identification number that an operating system gives a running process in order to be able to track it down. So what we're going to be doing is kind of correlating the process ID inside of our Windows virtual machine and then tying it into what's actually going on inside of our Wireshark traffic to do a compare and contrast. So let's go ahead and hop over to our virtual machine and let's see what we got. All right, so here we are inside of our Windows 10 virtual machine, and we're doing this inside of a virtual machine because we can kind of make sure that we're isolating everything. And later on, if we start getting into, let's say, like pen testing concepts, we want to stay in this isolated environment to make sure that we don't infect the actual host that we're working on. So as we see, this is our basic startup for Wireshark, and if you missed it, go ahead and check out that Introduction to Wireshark video. Now, I'm going to do a little zoom in here real quick because normally you could just select Ethernet 0 and go from there. But for me, I like to go in and do the little gear wheel that you see up there on the top left. We're going to click that, and that allows us to actually configure options. And when we go in there, what I look for is the promiscuous checkbox right here. And so we know that Ethernet 0 is the one that we're going to monitor on this particular system, and we can verify that by expanding it and making sure that the address is correct with like an IP config or an IF config inside of a Linux-based system. But as long as promiscuous is turned on and checked here, we can actually see all traffic going in and out over this interface controller and not just catch little snippets here and there. So we're going to go ahead and start with that one selected, and you'll start to see a bunch of traffic come open. Now, this is what we see right here is just basically the system talking to itself and the actual broadcast of the network that we're on. Now, while that's running, I'm going to open up Edge and go to Google real quick just to do a little bit of traffic. Now, do bear with me. This is a virtual machine, and I am running on a few limited resources here. So I'm going to go to google.com. Okay, we've loaded up. Now I'm going to go to youtube.com, and I'm going to start up a video so that way we can actually catch some TCP traffic in the background. I like football, so the first football one that we see is the one that we're going to get. Now, once that's playing, if it actually loads up, ads are fine too. We're going to minimize that and go down. Oops, I actually had the sound on that. So we're going to go and down to a bottom, and we're going to open up a command prompt. Now we can do this by hitting Start and R button and type it in CMD. And inside here, we're going to run the command netstat, Netstat, space -ANO. And this gives us a snippet of what's actually going on in network traffic. So like right now, it takes a snapshot of what's actually happening. Now with this open, I'm going to go ahead and stop my capture. And I'm going to go ahead and stop the video and close the browser because we actually have everything that's going on. And we can go and see inside of our Netstat some of the traffic that was here. Now I want to explain some of these columns real quick. So I'm going to highlight the first row here and then zoom in for us. On the left, we have starting off proto, which is short for protocol. Is it TCP or UDP? And then we have our local address, which is the actual system that we're on right now. And you'll notice that after the standard IPv4 address, we have a :135. That's the port that it's talking to on this local system. And the foreign address of whatever it's going to, which is the destination. So in the case of, for us, it was Google and YouTube, right? Well, the colon, and I know that was 0 right there, but you'll see some others right below it, which are not. That's the destination port. So if we're going to an HTTPS site, you'll see that being 443. And if it's HTTP, you'll see it port 80. We'll go into those in a second. And then the state, which is for TCP traffic. Now, we won't have this for UDP traffic because UDP is fire and forget, right? But TCP has that 3 phase of SYN, SYNAC, and ACK. And so is it current? Is it listening? Is it established? Is it closed wait? Is it time wait? Is it waiting for other stuff? And primarily what this means is if it's listening, that means that the program is still running, but it's waiting for some sort of traffic to come into it, and it has not sent a reset flag or anything like that. If it's established, that means the traffic's actually going back and forth at the time that we took the snapshot. Closed wait, which is meaning that the connection is closed, but it's waiting for a reset flag of some type. And then time wait is kind of similar. It's waiting for more traffic to come in, and there's usually nothing associated with it. It just means that the connection was there, and if it so happens that a process picks up on that, it'll go in there as well. Now, that's a watered down version of it. But let's go ahead and zoom out, and we're going to just pick on two of these real quick. And we're going to say, look at the first one here. Actually, we'll just look at this one since it's established. Let me zoom back. Oh, I got to remember that I'm on a VM here. And let's zoom in. Now, it's a TCP connection that's coming to us as the source. And then the 49675 port is a non-standard port. So the local system here is just trying to find something to receive it on. But it's actually going out and connecting to 20.7.1.246 on port 443. So this is an HTTPS connection. And if we see that it is established, that means it's currently going at the time of the snapshot. And on the right, we see that it was associated with process 1300. Okay, well, tell us more. Well, in order for us to be able to get more information about this, there's a couple of different places that we can go. First and foremost, we can go to the task manager and the event viewer. And first, we'll take a look at the task manager. You can get to this by hitting Control-Shift-Escape or hitting Alt-Control-Delete and then selecting Task Manager. Now, the standard view right here is what's going to pop up by default. And it just shows us kind of a very, very basic picture of everything that's open. If we scroll through, stuff in the background, apps that are running. But what we're looking for is the Details tab. And that's second from right next to Services. We'll click on that, and we can see in here, now it'll be sorted by name at first, that these are all the processes that are running on this system live. And then the next column, we have the PID, and that's the process ID. And so we're going to sort by process ID and see if process ID 1300 is still open. So let's scroll up a little bit, and do we have a 1300? There it is. So we know that svchost.exe, let me zoom in for you real quick, is the culprit of that connection. Now, what is it? Well, this is where having that task manager and in the details view helps us, because we can right click on that SVC host, go down to properties, and see where the actual file is. And it'll allow us later on, when we start looking at verification and validation of files, to see if this is a legitimate file and connection inside of Windows, because programs are what drive the connections in and out of this particular system. And so we can go into details and see if it is signed by a copyright, and we can go into the security tab and see who has the authority to open this on the system. We can go into digital signatures and see the actual certificate that's associated with this file, if it has one. But this also tells us where the files are at. And in this case, svchost.exe, which I have highlighted in blue, is stored in C drive Windows System 32, which is now highlighted in blue. So we can actually go all the way to where this actual file is and do further analysis if we wanted. Now I'm going to cancel that, and then I'm going to open up the event viewer. Now inside the event viewer, sorry about that. Let me do a refresh here real quick. Now you can search for event viewer by hitting start and starting to type in event viewer, and this will open up. I am inside the security log. Let me zoom in for you. Of the Windows logs inside the event viewer. Now the security logs allow us to be able to track audit successes and failures based on stuff that opens, closes, and if we access something with or without permissions for that. And in this case, we have a bunch of audit successes. So which one is which, and which one tells us what process ID 1300 was? Well, we can search for it a couple of different ways. First and foremost, we can go to filter current log, which is on the right and kind of looks like a wine glass. And when we click on that, we see here, I've already pre-filled it with, let me erase that and show you where it says all event IDs. And I'm going to zoom in for you here real quick. Where all event IDs is in there, we're going to replace that with a 4688. And that's searching for Windows Event ID 4688. And for those that know their event IDs, which I'm not one of them, I always have to keep a cheat sheet on me. This is the event ID that happens every time a process has been created on the particular system. Now, if we zoom in, let me scroll down just zoom in just a second and show us. In the general details, we can see in the first line, it says a new process has been created. It tells us who did it, what the system was, what domain they were on, and then the target subject, which is not really critical to what we're doing right now. But right below it, you'll see process information, new process ID, and new process name. And as we zoom out, I'm going to highlight here inside there, the process name is what we're trying to match up along with the process ID. Now I'm scrolling down just a little bit, and the one we're actually looking for here is creator process ID right there. That's going to correlate to what's actually inside of Netstat and also in the event log. Now you may be thinking to yourself, I thought we were looking up numbers. Well, we are. This is represented in hexadecimal and needs to be converted to decimal. Now, there are many different ways to do that, but one of the ways that I do it, let me move it over here for a second, is I go to Google and just look up hexadecimal to decimal converter. So we're going to go, let me move this over here for a second. We're going to copy the creator process ID. Make sure that's copied. I'm going to bring this over here. And then from hexadecimal to decimal, we have this, I pasted it in there. We're going to convert, and it's process ID 236. Now that's not the one that we're looking for. The one that we're looking for, let me move this back over here for a second, go into our Netstat and show us. We're looking for process ID 1300. So let's bring our converter back over and swap. So we're going to go from decimal to hexadecimal, and we're going to type in 1300 and convert. So we're looking for 514, which would actually be 0x514. Now there's a couple different ways to do this. When we go back into our event viewer, we can do a filter current log, or we can just do a find. And sometimes it's easier to do a find. So we're going to do a 0x514, and we're going to find next. And I'm going to close this, and we can see here, there it is. That's the process ID that we were looking for. And that gives us the information on the who, what, when, where, why, and how all this svchost.exe process was opened. Now you may be thinking to yourself, well, Eric, we haven't even gotten into the Wireshark stuff yet. What's going on here? I'm glad you asked that, because I'm with you. Now that we know how to track all this stuff down as far as process ID and understanding how the traffic flows from us to destination, we can now start taking a look at Wireshark and applying what we have in our Netstat inside the Wireshark. Now, we went to Google and also went to YouTube on our Edge, right? Right. So let's take a look at our Netstat here and see if we find anything that's imperative, because we are going to look that up too. So we know that we can go inside of here, start up at the very top of our event log, and start searching for MS Edge right there, right? So that is one of the many MS Edges that has been opened up. We're going to make sure that we can understand who opened it, which in this case, it was me. And we're going to convert that process ID in our hexadecimal converter, if I can find it again. There it is. And we're going to convert 0xEC over to an actual number. We're going to convert, and we're looking for process ID 236. Now, is 236 still open? Let's find out, because as you saw, I closed it a while ago, right? Well, let's go into our task manager real quick and sort by process ID. And wouldn't you know, it's still open. Why is that? That's because sometimes Microsoft Edge runs in the background. And this is good information to know when we're taking a look at our systems to see if we actually have everything closed or if we have connections that we don't know about. So now let's take a look at our Netstat and see if anything was running under process ID 236. Now, that may or may not have. That's okay. I don't really see anything in there as far as that goes, but we can actually start searching inside of our Wireshark to see if there was any traffic going to Google or YouTube and start piecing it together around timestamps. So we know that this was opened at 6:49:23, and we're looking for something around that ballpark. So this kind of gets into the nitty-gritty of how we log everything and correlate. So did it happen in Wireshark? Did it happen in, Netstat? Did it happen inside of the event viewer? And there's a whole lot of writing everything down to make sure that we could track everything down based on process ID hashes and all this other great stuff. So let's go ahead and go inside of our Wireshark here and start understanding what it is that we're looking for. Now, inside of Wireshark, we can actually apply a filter to look for frames that were captured during a certain time. Now, this is based on the actual system time that we're capturing at and what's in the actual frame itself. Just as a demonstration, let's take a look at an actual frame. We're going to select a random packet at random, that one. And then we're going to go down here and see inside the frame itself the arrival time. So let me zoom in for us real quick here. We can see that the arrival time was February 24th, 2023, today, at 18:46:09. So this tells us that this packet was sent somewhere close to our actual time window. So if we zoom out here real quick, let's zoom out and go back to our event viewer, we're looking for something in the ballpark that's at 6:49:23 seconds for that MS Edge application. Now we could easily search for a timestamp by right-clicking that arrival time and go to apply as filter and then selected, but that only shows us the packets for that one particular time. But what we can do is we can tap that in right there and make sure that we can get a to and from time that gives us kind of a window of what it is that we're looking for exactly. Now we are looking for something that's within 6:49 to 6:50. Now we need to remember that this is in 24-hour time, and that's why it says 18:49 on there and 18:50. Now that one frame is that we had selected already was at 6:46, so it shouldn't come up in the search, right? Now if I did my capture correctly, which I think I turned it off too early, we should get packets that match that criteria. But as I hit enter, I realized that I turned off my packet capture too early. So we're going to adjust this and back our time frame up a little bit and go to 46 and then 18:47. And that'll give us all the packets that happened within that 1 minute. Now, as you can see, that's a lot of different packets in there, which that's okay. But inside of this, we're actually going to be searching for some other stuff, because inside of our frame, that just tells us time, the size of it, and just the basics of it overall. What we're looking for is stuff about Google and YouTube to see what kind of traffic we had going back and forth and to figure out what exactly it was. So how do we search even further? Well, we're going to keep this right here as far as our timestamps go. We're going to add another search parameter, so ampersand, ampersand, and then we're going to type in another search parameter. Now, I have it zoomed in here already, and we're adding in the dns.qry for query.name equal quotes www.youtube.com. And as we can see here, that gave us a DNS query. So that's all traffic related to that query itself. Because remember, when we type in our actual address in the browser itself, that doesn't necessarily know what IP address it needs to go to. So this was the actual response of everything that was going on, and we start getting more detailed information. So let's zoom out of there real quick. And we're looking at our response. We're going to zoom down to the bottom of the frame or bottom of the packet, expand the DNS portion of it, and see if we had any answers. Now, this right here, let me zoom in. Almost. There we go. You can see that I had an answer of www.youtube.com type CNAME. Well, that's not really an IP address, but we're going to dig a little bit deeper to see if we can find one. So if we expand that, we can go down, expand that, we can go down. And we just have to take a look at a couple of these to figure out, oh, would you see there, address 142.250.138.93. And that's some traffic that we started going to. And as you can see over here on the right, let me zoom in on that for you, make sure we can see it. And you may have a little bit of inception for my OBS there, but you can see that we have youtube.com and google.com. So we're starting to hone in on some of the stuff of what's actually going on inside of our actual network traffic. Now, we're not going to go too deep in the weeds on this. That just gives us an idea of how we can search Wireshark for packets and start to ID if that IP address in the packet matches anything that we see here. So did we see any IP addresses from Google or from YouTube, like that 142.250, inside of our Netstat? Pretty sure we did. That 142.250 range right there is on a TCP on a wait with 443. Now that's not the exact IP address, but it starts to give us an idea of what to look for. And there's another one within that same subnet. Now, how do we know what's within the same subnet? Well, that's where tools like Whois, ICANN, and lookup databases help us out too. And again, we will be getting into those later. But this is just an overall assessment of how to use the task manager, the event viewer, to see what was exactly going on and look at the traffic on Wireshark at the exact same time. And paired with that packet tracer video that we did already, it tells us if we've actually sat down and captured traffic at the proper point of the network. Now, I know that's a lot to take in, so that's why we're going to kind of call it here. I just wanted to give a demonstration of how to search for a PID and also kind of give an idea of how to use Wireshark to be able to see traffic going back and forth and capture a particular time frame. Because if we do the capture correctly and we do the search parameters correctly, we can go in and see packets that happen within our little snippets from like Netstat and also our event viewer, because then we can compare and contrast timestamps to start to put together the pieces of the puzzle if an intrusion happened or if we just want to see what a user was doing. As always, thank you for stopping by. I appreciate every comment, every like, every subscription on here. It does nothing but get the word out for Panola College and the department that we have. Look forward to any comments, complaints, concerns, anything you got for us, and tell your friends about it. And as always, take care of yourselves.